So you should have 6 triangles in front of you. And this is going on page 84 when we're done. So 84 up here. So we're going to start by looking at these triangles and then triangles here. But we have 2 30, 60, 90 triangles here. And we reviewed special right triangles yesterday. So we know that we can label them. So I put my little right angle in here. And then this is 30 degrees. Across from 30 degrees is your short leg. Hypotenuse is 2 times the short leg. And then the long leg is the short leg times the square root of 3. Okay, so that's the labels we would use when we go and solve stuff. But the side lengths themselves are a pattern that relate to each other like this. But we can redo it. We crossed out the S's yesterday, basically that S is 1 and this, and this made the square root of 3 and this was 2. Go ahead. Yes, these are S's, not 5s. Yes. Yeah, just to make sure those are S's, not 5s. And then if my hypotenuse is 1, then what would the length of the short leg have to be? 1/2, okay? Which means the long leg would have to be what? Okay, and how would we write that? Square 3 over 2. Okay? And then if you look at your green triangle, so grab your green triangles and lay them down so they look like reflections of each other like this. This is very important. I was very careful when I put the sets together, but make sure you don't have to. Now the triangles are congruent, but make sure that they're not labeled identically. See how my green triangles are reflections of each other? So lay them out side by side just like this. And they should match these 2 triangles that are right there. Okay? So on the little triangles that are on the paper, put little right angles. And on the green triangles, put little right angles. Okay, because I didn't draw those when we did them. Then we're going to write some Roman numerals inside of them. The left triangle here is Roman numeral 1. Right triangle is Roman numeral 2. And do the same thing on the green ones as well. Left one is Roman numeral 1. Right one is Roman numeral 2. Okay. We all good with that? All right, so then we're going to move our green ones. And I want you to pick up your yellow ones. Set them down so they look like what's on the paper. Bless you. They should be reflections of each other like this. Okay, so make sure you have the correct sets, which you should. Again, I was careful, but not perfect. So then put right angles on both triangles on the paper and on these. And yes. Oh, dang. How do you have to? Why not? Then somebody else. Okay. Does anybody else have the wrong ones? Okay. I cut out the same thing twice then. Okay, they're the same. Okay, dang it. All right. Give me 1 second. All right, so now that we've got them with the right triangles, correct triangles, then again, Roman numeral 1 on the left, Roman numeral 2 on the right. Do that for the triangles. The right before we move on, because that otherwise it gets a little confusing. Well, with that, move those out of the way. Let's look at this here. Here we have 45, 45, 90 triangles. I'll label this little right angle right here. So to solve the 45, 45, 90 triangle, it's L squared of 2. Right? Again, your teacher may have used X's, but it's really not the best way to do that. Then again, I'm going to make the hypotenuse. If that's the case, then I need to figure out what the legs are. It's not quite as obvious as the other ones. So what I know, though, the way that we actually solve these is I know that L squared of 2. Let's do it this way. L squared of 2 equals 1, right? Hypotenuse equals hypotenuse. So then I divide both sides by the square root of 2, so L is equal to 1 over the square root of 2. Is that legal? No. So then I rationalize, and what is L equal? Square root of 2 over 2. So the hypotenuse then is, I'm sorry, not the hypotenuse. The hypotenuse is 1. The legs are square root of 2 over 2, square root of 2 over 2. It's 45, 45, 90, so they're congruent to each other. Okay? Everybody okay with that? All right, so then grab your 2 pink triangles and lay them down. They should be reflections. Make sure that the pink ones, because obviously not everybody had the right thing to begin with. And just flip it over, reflect it. Yeah. Okay, okay. Works out. Paying attention, we know we're trying to. All right, drawing the right angles on here and on the paper. And then again, Roman numeral 1 on the left, Roman numeral 2 on the right. Okay, everybody with me? So you should have all 6 labeled. 3 of them have Roman numeral 1, 3 of them have Roman numeral 2. Everybody good? So now when you flip over or open it up, you have this beautiful unit circle here where when you tree, you could what measures. I went ahead and just had both of those sets already filled in, so they were correct, they were neat, you could read them, and you know what's going on. We'll get to the ordered pairs. The ordered pairs is something that you talked about in geometry most likely. I think we did it here, but that was just that I went that far with this in there. But either way, we didn't really do anything else with it. But this unit circle has so many beautiful things in it, so many beautiful patterns. It's going to connect so much stuff together. And today we're just kind of touching on everything that comes out of this, and we're going to keep referring back to the unit circle and find more patterns, more things that are happening, and it's going to become very, very, very important to us. So with that said, I want you to take your green Roman numeral 1 triangle. So this triangle, I'm going to place it where the 30-degree angle, the vertex of that angle, is at the center of the circle. The long leg is on the x-axis, and then the vertex where the 60-degree angle is right on that point on the circle. So it looks something like this. Okay? So once it's all lined up, all nice and pretty, then take a little piece of tape. It doesn't have to be a ton. Kind of make it about a square. It's probably big. Right there. Take a triangle. Okay. I don't even know what it's about. All right, so this 30-degree angle, what is that 30 degrees in radians? Pi over 6. Good. So we're going to put pi over 6 right there. So this angle that's in my green triangle is the same angle that's here drawn on the circle, right? And you can see the little line that there is there for pi 6. That gets you that 30 degrees right there. So this is a unit circle, which means that the length of the radius is 1. Okay? So we've got some ordered pairs to fill in here. What this point right here, the unit circle, and the radius is 1. 1, 0. Okay? See how easy that is? Now I want you to think what this ordered pair right here would be. Just tell me what the x value of this ordered pair would be. Just the x value. 6, where does 6 come from? It's okay. Well, could it be more than 1? Like if this x value is 1, if 6 would be like way the heck out there, right? It's going to have to be less than 1 no matter what. But I want you to think about how you plot a point. When you go to plot a point, where do you start? The origin. You start at the origin. So if I'm going to start at the origin and get myself to that point, how far right do I go? But the pi over 6, that is, that's an angle measure. 3/5. You are trying to get to this point right here. And if you're going to plot this point right here, start at the origin. And I want to know how far right you go. Put your pencil kind of on it and think, I'm here, I'm going to go to the right, and then I'm going to have to go up. I want you to think about what those x and y values would be and where they might come from. Very good. So you're from here at 0, 0. When I go to the right, look, the length of this side of the triangle is the square root of 3 over 2, right? So I go to the right, the square root of 3 over 2 units, and I go up 1/2 of a unit. These lengths, that's why we put this right triangle on there. The x value is the square root of 3 over 2. Y value is 1. Okay. That's why we're doing this, so we can actually see it and make a little bit more sense. Now I want you to take this triangle. You are going to reflect it down across the x-axis. Now I know it's a little wonky right here. We'll fix that in just a second. Don't tape anything yet.
Miss, did we do this freshman year?
Yeah. And then, so there's my right angle, and the angle measure, this is 30 degrees, right? Oops. This is 60 degrees. This is my 90. This length here, remember this is like my x value. This is the square root of 3 over 2. This is 1/2. What's the length of the hypotenuse? 1. What part of the circle is the hypotenuse? The radius. The radius is 1. Okay. And then that 30 degrees is pi over 6. And what quadrant am I in here? Fourth. Okay. So once you get your triangle all labeled, then if it's, kind of gotten a little crooked, or if it got pulled down, you can kind of roll it back up. Put it in the position where it's on the vertex is at the origin, the other one's over here. Once you've got it all nice and straight, then take another little piece of tape and tape it down on this side. That way we can reflect back and forth and it won't be all wobbly. Okay. Now I want you to look at this ordered pair right here. What is the x value for this ordered pair? Square root of 3 over 2, and then negative 1/2, because we're in the fourth quadrant. And everything in the fourth quadrant is positive x, negative y. And it's coming from this same triangle. And just like the point's just a reflection in the x-axis. And all you do when you reflect in the x-axis is change the sign on y. That's it. Okay? We good? Good so far? All right, so now I want you to take your Roman numeral 2 green triangle and set it down over here. Ideally, we would just have one green triangle, but we'd have to attach it here at the origin, and that's kind of hard to do at a point. So we're just going to pretend like this one reflected over the y-axis. But once you get it set down and it's all accurate, as accurate as possible, then take a little piece of tape and tape it down right there. That 30 degrees is pi 6 in radians, right? So remember, what is labeled on the triangles are lengths of sides. So they're all positive, because side lengths are always going to be positive. But this shows me here that when I have this 30-degree angle, then this ordered pair right here, what is the x value? Negative square root of 3 over 2, and then a positive 1/2. Since it's in the second quadrant, it's a negative square root of 3 over 2, and then a positive 1/2 to get to that ordered pair. For algebra 1, when you start points before algebra 1, second quadrant, you may not have called the second quadrant at this point, I don't know, but everything over here, anyway, is always a negative x, positive y. Same thing holds true. Doesn't matter if it's a circle on there. We're taping triangles. Exact same rules. Okay? So now we're going to take this and reflect it down. Don't tape yet, because then you'll regret it, because you can't really write over your tape yet. Or tape well, anyway. So there's my right angle. This is 30 degrees. This is 60 degrees. Side lengths of the triangle, this is square root of 3 over 2. This one is 1/2. This is 1. And which quadrant am I in right now? 3. So this is my third quadrant. And this is pi over 6. Okay. So then once you do get it labeled, you can straighten it back up. You might need to push it back up to the x-axis somehow. No, let's not go there. All right, so then that means this ordered pair down here is going to be negative square root of 3 over 2, negative 1/2. Okay. Everybody okay with that? So if I flip this back up, and I'm going to zoom out a little bit so you can just see these points that we have plotted, or that we have written down. Ignore that 1, 0 for right now. But these 4 points that we just did, same right? And this is all for 30 or pi over 6, and they're all the ones that are closest to the x-axis. The reference angle for all of those angles is pi over 6. That's the reference angle. This angle right here is actually 5 pi 6 or 150 to get to this point, but the reference angle is pi 6. So when I know that these points relate to pi 6, and I'll show you a way to do that, once I know that that relates to pi over 6, then I know all 4 of those points like that. I can get my reference angle. Way easier than reference angles in degrees. Once you get it, you'll get more and more comfortable with radians. Okay? We're all good so far. All right, so grab your pink Roman numeral 1 triangle. You're going to set it down right on top of your green triangle like this. Line it up all nice and pretty. Vertex at the origin, vertex on that other point. And a little piece of tape there. 45 degrees, what is that in radians? Pi over 4. Okay. Pi over 4. Because it's half of 5, right? And 45 is half of 90. So when you're at 45, when your point has rotated 45 degrees or pi 4ths radians, then the point that started at 1, 0 is now at, what's the x value? Square root of 2 over 2. And what's the y value? Square root of 2 over 2. It should make sense that they're the same because that's a 45, 45, 90 triangle, and the legs are congruent because it's isosceles. Right? Okay with that? So we're going to take the pink triangle and we're going to reflect it down. Label our right angle and our 45s. The angle is pi 4ths. This side length is the square root of 2 over 2. This one is also the square root of 2 over 2, and this one is 1. What quadrant am I in? 4th. So once you have that all labeled, straighten it back up. You might have to push it up against the green one a little bit and make sure it's in the right spot. Then when you put the tape down, you're actually going to tape the pink one to the green one and a little piece of tape there, and that's fine. It'll work just fine to help us reflect up and down. Okay. So then my x value in the 4th quadrant, my x is positive. It's the same as the x value was in the numerator, square root of 2 over 2. Y value for the 4th quadrant is negative, so that's negative square root of 2 over 2. Right here. Any questions at this point? Okay. Then I can reflect it back up and move on to the Roman numeral 2 triangle. Line that up. Tape that down. All right, so now we're in the second quadrant. You want to pretend like all we did was take this first quadrant pink one and reflect it over there, but it just makes it hard to happen at a vertex. So now I have this 45 up here, 45, 45, 90. I'm in the second quadrant, so my x value is negative, and that's negative square root of 2 over 2. My y value is positive. That's a positive square root of 2 over 2. Then once you've got that, then you can reflect it down, start labeling. Let me know if I'm losing. I feel like. This is pi fourths. Side length here is square root of 2 over 2, square root of 2 over 2, and 1. What quadrant am I in? 3. So then I'll got it labeled, so I'll straighten it all up. Put another little piece of tape there so I can reflect. Since I am in the third quadrant, it is negative, negative, so that is negative square root of 2 over 2, negative square root of 2 over 2. That go with this. We've got 225, which is 5 pi over 4, and 135, which is 3 pi over 4, and 315, which is 7 pi over 4. They're all over 4, and they're referencing all pi fourths. It's that easy. All right. Any questions at this point? Are we all done with our pink over there? I don't want to rush you. But okay. So let's grab our Roman numeral 1 yellow triangle. Set that one down right on top of the pink like this so we can see the measurements that way. Tape that down. What is 60 in radians?
Pi over 3.
Pi over 3. 60 is pi over 3. 30 is pi over 6. Okay, so just the 6's and the 3's go together. Hope that can help you a little bit. So this ordered pair, the x value is 1/2. The y value is square root of 3 over 2. So if you look at what happened for pi 6 and pi thirds, x and y just flip. They change places. Because that's all that happened with the two sides, right? They just switch places. That's all it is. Okay. All right. And then I can reflect that down. And this is my right angle here. This is 60. This is 30. This is pi thirds. This side length then is 1/2. This one is the square root of 3 over 2. This one is 1. In which quadrant am I in now? 4. Once you've got your triangle straight back up, then put a little piece of tape down to anchor it. This ordered pair here, on the fourth quadrant, so my x is positive, positive 1/2, and then negative square root of 3 over 2. Okay. Bear with me. All right, so then we're going to take our last triangle, put him where he goes. I'm going to label this 60 as pi thirds. That's my reference angle. Do you see how the reference angles work? They get to the x-axis. My yellow triangles, the reference angle for whatever angle those end up at is pi thirds every single time. It goes back to the x-axis. It's always acute and it's always positive. So then the ordered pair here, this is a negative 1/2 and a positive square root of 3 over 2. Bless you. Then I'm going to reflect it down and start labeling. So I've got my right angle. This is 60. This is 30. This is pi thirds, because really this point is at 240 or 4 pi thirds. My reference angle is pi thirds. It's created with the terminal side and the x-axis. This is 1/2. This is the square root of 3 over 2. This is 1. And which quadrant am I in right now? Third. Line all this back up. Put my tape down. Like so. So now my x value is a negative 1/2, and my y value is negative square root of 3 over 2. All right. So now, 3 points that we have not filled in. So what is this point up here? Is this going to be 0, 1, because my x value is 0, my y value is 1. This point over here is going to be negative 1, 0. And then this point down here is 0, negative 1. Now this is really pretty, and it's really cool, and you can see lots of patterns in here with all these numbers, right? But let's talk about why we care. Like, why does this even matter? Why do we need these points? What does this even mean, right? Top left of our notes for that. So up here is what we're going to write this. Oops. So we're going to write in here sine of theta. So from SOHCAHTOA, what is sine of theta? Oh, you can't even see that. Sorry. There we go. What does SOHCAHTOA say sine of theta is?
Oh, the unknown angle.
Oh, it's what over what? Y'all are going to make me cry. Opposite over hypotenuse. SOHCAHTOA is SOH, so this is equal to, ooh, we have to know that, guys. Opposite over hypotenuse. So now I want you to come back. We're going to come back over here. I'm going to have to slide this, and I know that this thing's kind of jumpy. It's annoying, but I want you to come back over here, and we're going to look at this green triangle. I want you to take your ID badge. We're going to use it as a straight edge real quick. And we're going to draw in, basically draw in where that green triangle was. So you can push your badge up against the green triangle and slide it over a little bit, and then just draw in here so that we get a little right triangle. So this angle right here is theta. This specific one is 30. It could be any of them, right? So just want to look at it as theta, right? Theta is opposite over hypotenuse. Then this right here is the opposite side. Do you agree with that? This is the opposite side of that triangle. This length is this y value. Does that make sense to you? That's true for all of them. The opposite side from theta, that length is the y value every single time. So opposite over hypotenuse is going to be equal to y. And what is the length of the hypotenuse? Okay, yes, but don't write 1. It is 1, and you're right, and we're going to get there in just a second. So that means that sine of theta is equal to y. This is important to us. And I'll bring it all together in here just a second once we get it all finished. So then let's go down to the bottom left, so we have some room down here. Cosine theta, oh, I was about to write sine again. So cosine theta from SOHCAHTOA is what over what? Adjacent over hypotenuse. Good. Yeah, the ka part of it. So then when I go back to this little triangle we drew in, we just said that this length right here represents the sine of theta. So then adjacent over hypotenuse, the adjacent is your x value, right? Over the hypotenuse, which is the radius. So we're going to have x over r, and then in this specific case, the radius is 1, so that's x over 1. So x is equal to cosine theta. These little ordered, every ordered pair on this unit circle, and we'll write this in the bottom right because this is the only we have, is cosine theta, sine theta. Any of y'all in AP Physics? Okay. All right. Because I don't know that you've done this in on-level physics yet, but they've talked about vectors in there, and they've talked about mg cosine theta, mg sine theta, and that mg basically is the radius when you're looking at vectors. And so if I used this one instead of the x over 1, and I solved for x, I would multiply both sides by r, and I'd get x equals r cosine theta. So that r cosine theta and r sine theta, that is the mg sine theta, mg cosine theta from physics. I just don't think that connection is ever really made. But this is what this means. Okay, well, we labeled sine, so let's put cosine over here. This is cosine of theta. So I told you the other day that not only do we have to know our radians, but we have to know like what the cosine of 30 is, sine of 30. Those are things you're expected to know. If you know your unit circle, and really all you have to learn is the first quadrant, because things just keep getting repeated and signs change, is this. Because what this tells me here is, so here's 45, right? So guess what? The cosine of 45 degrees is square root of 2 over 2. 2 over 2. When I look at this 60 degrees, the cosine of 60 is 1/2. Sine of 60 is the square root of 3 over 2. You see how that works? It will make more and more sense, I promise you. Right now, you need to recognize it and be like, oh, okay, that makes sense that it is that. Don't start stressing out over the fact that you have to know it at this point, because I'm going to help you with ways to learn it, okay? Don't worry about that. Now, let's go up here to the top. And I've got tangent of theta. So SOHCAHTOA says tangent of theta is what over what? Opposite over adjacent. Which means that for these triangles, your opposite was y and your adjacent is x. So tangent of theta is equal to y over x, right? What does y represent in our ordered pair? The sine. So tangent of theta actually equals sine of theta over what? Cosine of theta. So let's say that I want the tangent of pi thirds, which is 60, right? That's sine over cosine. Guess what? The sine is the square root of 3 over 2. You don't have to write this down anywhere. Just stay with me. We'll do this a lot. Square root of 3 over 2 over the cosine, which is the 1/2. And then that means I get square root of 3 over 2 times 2 over 1. So the tangent of pi thirds is the square root of 3. Oops, I'm off the page. Okay, so do you see how that works? I just put sine over cosine, and I got those values from the ordered pairs, which will make tons of sense. I know that. It's okay. Yeah, that's right now I want you to look at it like, okay, this makes sense. And then if you can't tell me what the sine of 45 is right this second, it's okay. We're going to get there, okay? So take your ID badge. I'm going to draw one more thing. And so we put it, you're going to have to kind of flip these triangles back here. So put it here so that we could draw in that line segment, right? So basically you're just going to move it over to the right. So it's still pushed up against here because we want it to be perpendicular. And you're going to draw a ray. You'll draw these points you wrote, and that's fine. You're just going to draw this till you get to this point right here, and you should get a ray that goes right there that is perpendicular to the x-axis. Do you see that? You're going to draw right through the ordered pairs, and it's okay. Then you're going to take your ID and you're going to extend this hypotenuse from that 30. You'll extend it probably right through your square root of 3, and that's okay. And it looks like this. And then we're going to label this point A and this point right here B. Now, do you see the two overlapping right triangles? I have one that I drew in green and one that I drew in blue, but I don't know if you can tell the difference in colors on there. But so this right triangle and I have this right triangle. You with me on that? Are they similar? They are similar. And one of the things you have to still know from geometry as far as similarity is concerned is how to prove that triangles are similar by angle. That's important. It's going to come up in calculus. That has to make sense to you. The angle similarity postulate says that if two angles in one triangle are congruent to two angles in another triangle, then the triangles are similar. All right? They share this angle right here because they overlap, and then they both have right angles, which means the triangles are similar, right? You've been dealing with similar triangles like forever. All right, and so you know how to set up proportions. So I want you to think about this. We've got this blue triangle here. I can put sine of theta. So this side corresponds to line segment AB. Right? So I can put AB over the AB for cosine, right? For cosine. So guess what? The length of AB is equal to the tangent of theta. So that we can label this length here tangent of theta. And here's why I want you to see that right now, because I know there's a lot going on right now, and I'll show you another picture tomorrow where there's a lot more. Now I want you to take your ID and this green ray that I drew, I want you to extend it on the other side of B so that it looks like this. See how I just extended it at that time? How is that line, now because it was a ray, now it's line, how is that line related to that circle? How many times does it intersect the circle? One. Well, it touches at point B, right? So it intersects at one point. What's the name of a line that intersects at one point? Tangent. That's why a tangent line is called a tangent line. When you learn tangent line, you're not ready for stuff. Twice. So that segment that ends up representing the length of the secant is going to intersect with the circle twice. That's why it's called a secant line. Okay? So all of this stuff is going to start to come together more and more. There's a lot going on, but it's going to start to make a lot of things make a lot of sense. If you're practicing what I'm telling you to practice, when I'm telling you to practice it, you're going to be okay. I'm going to help you learn it. Not freak out that there's so much and that you have to memorize it. It's going to be a process. But as we go through it and we don't resist the process, it'll all make sense in the end. Okay? Are we good? Because this is just the tip of the iceberg as far as what the unit circle tells us. We're going to do some really cool things with it. But you can't do it all in one day because first of all, there's not enough time. And second of all, you need some processing time on what we've all figured out. So make sure you know your radius. You'll angles very soon, I promise. Know that if I go around here and I said, what is the sine? What's the sine of, or I'm sorry, what's the cosine of 3 pi fourths? It's negative square root of 2 over 2. And if you can't remember which one comes first, the cosine and sine, they're alphabetical, just like x, y is. X comes before y, cosine comes before sine. Okay, so those are your x and y values. Everybody okay with that? Do not lose this. We're going to going to be very important to you. So go ahead and glue or tape it in so that you don't lose it. And we're going to look at it some more tomorrow and talk about some more cool things happening with it.